Okay, so I'm on page 235, 225, and we're just going to take this is a review of AB to the X, which is right here. So we're going to take $500 and initially put it in the bank and increase it every year by 6%. I'm going to do this on a spreadsheet though, so I can show you the difference between what Excel's kind of doing and what you can do easily on your own for specific questions, okay? Okay, so here is our year, and here's our initial investment. The rate is going to be increasing by 6%, and the factor is 1.06. So I'm going to do this recursively. So basically, I'm going to take the $500 and increase it by 6%. So now I could drag this down, but what it's doing, see, the equation in here is 500. Let me put it over here. 500 times 1.06. So that's what's in there. That's what's in that cell. So now when I drag this down one, it's going to take the 530 and multiply it by 1.06. Another way of looking at it would be, this is 530. So it's just 500 times 1.06 times 1.06. Because this is this. So now I'm doing it twice. And if I do it all the way down to 10, I get that much money. You can see how the first year it grew by $30, the second year by $31, the third year by 30. So it's not a linear function, it's an exponential function, and it's growing by 6%. Now, in this cell, it's really 500 times 1.06 times 1.06 times 1.06. All right? It's just displaying what this number is, and then it's using this number and increasing it by 6%. But you can see how repeated multiplication can be seen as exponentiating, right? So let me do this a different way. I'm going to start at $500, and I'm going to use this formula. That's the initial value A. So I'm going to start here. I'm going to take the initial value A, which is not going to change. I'm going to multiply it by 6%, 1.06, which is not going to change. I'm going to raise it to the first power. So that just means 1.06 multiplied once. This would be 1.06 oh, what do I do? Oh, well, I don't want to use 1. That's what amateurs do. So that's 1.06 multiplied to the first power. And this is going to match up because this is the same thing. This is 500 times 1.06 times 1.06. But it's raised to the second power. And likewise, all the way down, it's going to be exactly the same. Now, what's nice about this is I can say, okay, well, what am I going to have in 30 years? In 30 years, what am I going to have? Boom, there it is, right? So all it did here is go the output equals 500 times 1.06 raised to the 30th power. And that's what's nice about the formula. If you're looking for a specific answer, there it is. So just to review this formula, you have a starting value is A. B is your factor, and raised to the X is how many repeats of 1.06 you want, or whatever this number is. So this is a good problem. All we have is you initially put in $1,200 and now you have $1,500. What is the rate increase and what is the factor? Well, to do that, you'd have to find out what the percent difference is here, right? So it'd be, you would take, what's the percent change? And recall, that's what the percent increase was. So put that in your calculator. And you should get 25%. And we're going to prove it in a minute here. But what factor is associated with the 25% increase? So this 1,200 to 1,500 is a 25% increase. So that's the rate. You could put it right in there at 25%. We have it here. Now, what do you multiply 1,200 by in order to get $1,500? And that would be the factor. So that is simply 1, in this case, plus 25 over 100, which is 1.25. So let's see, does that work? I mean, 1,200 times 1.25 equals, put in your calculator, and indeed, it is $1,500. So when you have a table of values, sometimes you can determine what the rate and the factor is from the increase. Okay, so here we're going to find what the rate and the factor is for this problem, knowing that it's exponential. You have to know that. Otherwise, you can say, well, maybe it's linear, right? But knowing and being told it's exponential, what is the rate and factor? So to find the rate increase, the percentage increase, what percentage did 200 increase by to get to 216? So we do that like the way we did it in chapter 4. 216 minus 200 divided by the original 200. And then as a percentage, multiply it by 100. And I think you see that you get 8%. You do it on a calculator. So the rate is 8%. The factor is 1 plus R. So the factor is what you multiply 200 by in order to get 8%. So 1 plus 8 over 100, which is 1.08. Okay, so I'm just going to put my y's over here. And I'm going to build my formula. Y equals the initial value times the factor raised to how many you have. How many times you're repeating that. Here I'm not repeating it at all, it's just 0. But any number raised to the 0 power is 1, so you get the original value. So I already got part of this built just by looking at it. There's the initial value. There's the rate. And then it is the input. gonna start here. I'm just gonna put 200 because that's what I've got. Now I'm gonna match this to 16. So I'm gonna use this equation here. Equals 200, which doesn't change. That's the initial value. Times the factor, which doesn't change because that's the factor. Raised to the, in this case, the first power. And there you go. You can see that we develop an exponential. Increases by 16, increases by 17 point something, increases by 18 point something. So it's not a constant rate of change, it's an exponential. And there's the formula for it, which we built.